Well, there's your first plexer. Go ahead and give it a shot. Pause the video if you don't want to hear the answer. The answer is focal point. Focal point. 4 cals and a point. There you go. Find the equation of the line. So I'm going to go through these problems one by one, step by step. If you want to go ahead and fast forward, if you think you know the answer, go ahead and fast forward till you see the answer, and then if you need to go back, you can do that as well. So anyway, what I'm going to just go ahead and do these problems using, in this first one, I'm going to use the product rule, noticing that we have the product of two functions. And in using the product rule, just help you reinforce that. But in all actuality, I would probably just multiply these out. I would just multiply out the trinomial times the binomial. I'd get one big long polynomial, and then I would take the derivative of each of the terms and end up getting the same thing. But nevertheless, I'm going to do the product rule because I know you're just learning that, and just give you some more practice on that. So the product rule is the derivative of the first function, I should say, x squared minus 4x plus 2 times the derivative of the second function, which is 4, plus the second function, 4x minus 1, times the derivative of the first, which is 2x minus 4. Okay, so there's no need to simplify. It says we want to find the equation of the tangent line at the indicated point. So when the x value is 1, we have y prime at 1, and we're just going to plug in 1 for every x that we see. So we get 1 squared minus 4 times 1 plus 2, multiply that by 4, add to that, 4 times 1, subtract 1, then we're going to take our 2, and we're going to multiply that by 1, and then we're going to subtract 4 from that. That's a lot of work there, and I really don't like the lack of space that we get on these, so I'm going to use a separate piece of paper. So inside this set of parentheses, 1 minus 4 is negative 3, negative 3 plus 2 is negative 1. We're going to multiply it by 4, plus, and then we have 4 minus 1 is 3, and we're going to multiply that by 2 minus 4, which is negative 2. So I don't want to try to do too many steps in my head. Negative 4 plus negative 6, which is negative 10. Okay. Well, negative 10 is just the slope. And if you remember, we were asked to find the equation of the tangent line, and so I want to reiterate that the point that we're going to be finding this equation for is the point 1, negative 3. So therefore, we know that since y minus y1 is equal to m times x minus x1, we're just going to replace the y1 with the negative 3, the m with the negative 10, and the x sub 1, or the x1, with 1. Okay? So again, just to reiterate, the slope of the line passing through the point 1, negative 3, or the slope of the line tangent to the graph of this function at 1, negative 3 is negative 10. So we're using, just want to make sure you understand this, we're using calculus to find the slope, and then we're just using algebra to find the rest of this, because we already know how to find the equation of the line given the slope and the point. Okay, it's just the point-slope form that you learned back in Algebra 1, and that right there is the answer. Okay. Doesn't look like I left myself a lot of room for the second problem, so B, and so let's do that down here. Okay. So B, let me get more light here. We have the function y is equal to x minus 4 over x squared plus 3, and we have the point 2 comma negative 2/7. Doesn't look like a very convenient problem, but nevertheless, y prime using, here we have the quotient, or a quotient. Y is a quotient, and so we're going to use the quotient rule to find y prime. Now, y prime, remember, the quotient rule is low-d high, high-d low. Okay, so low, meaning that the function in the denominator, so low, d high, derivative of the numerator, minus high, x minus 4, d low, and the derivative of the denominator is 2x, and that's all over the denominator, x squared plus 3 squared. Okay, so y prime when x is equal to 2, so here the x value is 2, so y prime at 2 is a specific specific slope. Okay, so this y prime here is a function of x. When we replace x with a specific value of x, well, then we have the derivative at that specific value, in this case 2. So the derivative at 2 is going to give us a number. Derivative at 2 is the slope of the tangent line to this function when x is equal to 2. Okay, so when you replace x with 2, let's try to do more of this in our heads. 2 squared is 4. 4 plus 3 is 7. Minus, and then this is too much for me to do in my head here. 2 minus 4 is negative 2. It's just too easy to make a mistake. 2 times 2 is 4. Okay, that's all over. 2 squared is 4. 4 plus 3 is 7. And 7 squared is 49. So we have 7 minus minus, which is plus, plus 8 over 49. And so we get 15 over 49, and that does not factor. Okay, so here we have our slope, and we want to make sure we remember this. I always like to go back to this. I write slope right there, and then I rewrite my point, 2 comma negative 2/7, and then I just replace here's our x1, our y1, and I replace that in this formula here. Y minus y1, which is negative 2/7, equals the slope, 15 over 49, multiplied by x minus 2, and I'll let you simplify that. Y plus 2/7, and just leave it alone. Okay, so there's the first two problems. Let's see what else we have. Determine the points at which the graph of the following function has a horizontal tangent. Alright, so a horizontal tangent, this is really good stuff, because then now you're taking, instead of just learning the rules and applying the rules, now you're actually not only learning the rules, but you're learning how to apply them and to solving problems where you actually have to think a little bit more. If you think about it, a horizontal tangent line has a certain slope, and you should be remembering this, that a horizontal tangent line or horizontal line has a slope of 0. That means that y prime would equal 0. And the question is where, or for what values of x does this function have a derivative of 0? Okay. Well, the first thing you should do, besides just understanding what it means to be a horizontal tangent, is you should understand that x cubed, this is really helpful when you understand what the graphs look like. X cubed with a positive leading coefficient looks like that. Okay, so we're going to have 2x values probably, and sometimes it looks like this, where there's just one little spot right there, which we have one horizontal tangent, but most of the time when there's multiple terms especially, we're going to get two horizontal tangent lines, two bumps on an x to the third graph, and so forth. So let's see if we can find those values. Y prime is equal to, okay, so we have 8/3 multiplied by the derivative of x cubed. So we're using the constant multiple rule, and the derivative of x cubed is 3x squared, plus 5 times the derivative of x squared, which is 2x, minus 3 times the derivative of x, which is 1, and then minus, and I know the derivative of every constant is just 0. Okay, now the 3's are going to cancel here. Let me get my handy red pen. And so we get, sorry about that one, we get 8x squared plus 10x minus 3. Now, chances are, because this is one of the first problems that we've done, you're going to be able to factor this polynomial, and I hope it factors. I'm going to always choose the middle two factors, 4x and 2x, because again, I'm going to end up trying to set this equal to 0. And if we put a 3 there and a 1 there, and they get 12x, which is positive, minus 2x gives us 10x, and so that's how we factor it. Okay, we're supposed to determine the points at which the graph of the function has a horizontal tangent. Well, the first thing we have to do is find the x values in which, let me back up a little bit. We need to find the x values in which y prime is equal to 0. So y prime, just so you understand the whole thing here, y prime equals 0 when 4x minus 1 equals 0, and also when 2x plus 3 equals 0. So in other words, when we solve these two equations for x, we'll find the x values in which the y prime is equal to 0. Okay, and we can see that x is equal to 1/4 here, and we can see here that x is equal to negative 3/2. Subtract 3, divide by 2, got it. Add 1, divide by 4, got it. Okay, So these are the two x values, and when you plug these two x values in, it says the points. I really don't want to plug 1/4 in and cube it, and then plug 1/4 into this and square it, that kind of thing. So I'm just going to go ahead and let you guys just leave it like that. As long as you can find the x values in which this graph or this function has a horizontal tangent, then you're good. I'm going to just leave it like that. Because y prime at 1/4 is 0, y prime at -3/2 is also 0. Okay, so leave it like that. Don't have to find the y coordinates there. All right, next. This is fun stuff, isn't it? Let's see if I can squeeze it in here. We've got y. Oh, good problem because it's a quotient. So y prime equaling the low, x squared plus 1, d high, which is 2x, minus the high, x squared minus 3, times the d low, which is 2x, all divided by low squared, x squared plus 1 squared. And that denominator will never be equal to 0, because even if x is negative, that whole thing's positive. If x is 0, this whole thing is also positive. So the denominator, we don't have to worry about any discontinuities in our graph. All we have to do is set the numerator equal to 0. Okay, but so let's do that. Y prime equals 0 when, let's multiply it out at the same time. 2x times x squared is 2x cubed. You've got to be really careful here. Plus 2x, okay, minus. I don't like to do this, although, yeah, I don't want to do this. I want to put minus, and then 2x times this guy would be 2x cubed minus 6x. Okay, so y prime equals 0 when the numerator of the fraction is equal to 0. Okay, and so we just have to solve this equation. I didn't want to do too much there. I've got a minus sign and I'm distributing. I could run into some trouble here, so I don't want to do that. So we get 2x cubed plus 2x. Now I can distribute minus 2x cubed. Good, I get rid of that 2x cubed. Plus 6x is equal to 0. So the 2x cubes are going to cancel. And then I'm going to get 2x plus 6x, so we get 8x is equal to 0 when x is equal to 0. Seriously? When x is equal to 0, that's it? Interesting. Okay, so when x is equal to 0, we can easily solve this. Then y is equal to -3. So the point at which the tangent line is horizontal would be at 0, -3. Okay, and so that is your answer. I don't know if I can squeeze one more in there. Maybe I'll leave it like that, and then I'll make a new video for the rest of it.